Here we're going to talk a little bit about a couple issues and just some reminders to different things. So you may have noticed when we place the shift register in another video or right here that there seems to be something missing, the power pins. By default, a lot of the schematic here we're going to talk about a few things and a couple reminders. You may have noticed in another video that there seems to be something missing from this chip. There are no power pins on it. In order to get them, you need to click on it, right click, and edit properties. Scroll all the way over on the parts tab and you'll see power pins visible. Select that and then get out of property editor. It's going to apply it and just click yes, and now you'll see the power and ground pins. These automatically link up to the VCC and the ground normally, but sometimes we want to show them, or we might have a different symbol instead of the ground or VCC if we have multiple power rails. So we're just going to do a wire coming off there and a wire coming off of here. And then we can just copy this symbol. There's a reminder that you're going to want to non-connect any pins you're not using. So hotkey X or this little no connect over here. And then for the net alias, this might be a time when you would want to use one, even though this is part of the same package over here. And instead of running this all the way around, you could just do W or select the wire. It needs to have a lead to where this disappears, so just a small wire. And then N, or again, this net alias over here. And for this, it's just going to be SDO, or serial data out. And just click on the line, or the wire, I should say. And now these are electrically connected. For this, we're just saying that this header is going off to the microcontroller off the board. One thing to note about net aliases is you never want to use spaces in the name. So you would never do something like that, because that's going to throw some issues when you start creating these net aliases. So just make sure that you always have no spaces in the net alias name. Here we're going to talk about applying footprints to the different components in your schematic. So the schematic doesn't have to match up to how it's actually going to look on the board. If you notice here, this is not how the pins are going to be laid out when you're looking at the actual package. You'll never have a situation where you have more pins on one side than the other, and it's kind of odd that they're going to come out the top and bottom like that. When you make your custom schematic, you can move around the pins in order to make it flow better. So all these are the outputs, but you see how all these would be on one side and then this would be on the other side of the board. You want to make sure that when you make the footprint or you assign one, that it's laid out the same way you would on a data sheet. So here we have the 74HC595. So I've already pulled up the data sheet for it. And there's the component, and you'll see that it's part of the name. When you're searching for this in your part search, you want to use the most basic version of the name. The NE4 and the SN are just different properties for the 74HC595 shift register. So whenever you're doing searches, just do that basic version. But here we have the shift register, and on here is going to be a pinout. So despite what that schematic symbol look like, the footprint will look and have the pin layout like this. One of the things we need to look at here is what's the package type. So when you buy the product on DigiKey or Mouser, somewhere on here you're going to see package. This is a DIP 16 or 16 DIP, and on the data sheet you'll also see all the package types. So on here, these are a number of different packages: PDIP 16, CDIP 16, and it just depends on what type you have. When we go back to the capture, you go and you show footprint, and there's no footprint assigned to this right now, so you're not going to see anything. And that was right click and show footprint. In order to put a footprint, you're going to go to edit properties, and then PCB footprint. You're going to enter a name. In order to know what this name is, you need to know what that package type was. So we were doing a DIP 16. Over here, I've already done a search for, this is a very common one, cap196.dra. The DRAs are the footprint types, and you can see that this is the file path that this computer uses in order to get to where all your footprints are. So we're just going to open this file location, and now you'll see all of the footprints. So that one was a DIP 16 for the shift register. So we're just going to type in DIP and see what pulls up. So DIP 64, let's type in DIP 16. Here we go. So we're going to apply the DIP 16 underscore 3. It might be underscore 3 because it might have been updated or someone threw in another package of these. But you need to have this exact name. If it's all caps, it needs to be all caps. If it's all lowercase, all lowercase. So in here, we're going to do DIP 16 underscore 3. And enter. And now that part is in there. Exit the property editor and apply the changes. Apply the changes. And we're going to go back and show footprint. And now you can see that footprint there. And you can look on the data sheet and see that it looks the way it should. So 8 pins, 8 pins, and this is a very, very common package type. So a lot of these, when you see the SOIC, PDIP, all of those, they're going to be in there. And just search again that package type and then the pin number. Here we're going to talk about placing some of the footprints on common components like resistors, LEDs, and headers. In one of the videos, we went and navigated to where the footprints are, and we're going to go ahead and do this again real quick. So OS, Cadence, inside silent, and then from here I'm not 100% sure where it is. So what we could do is do asterisk.dra, and it's going to search and find all of the DRA files, anything with any name and DRA at the end. And you can see that there's a couple of different file paths here. Tools, libflow, template. We don't want it. And what we're looking for is this one. So share PCB lib symbols. So we're just going to go ahead and open that file location. So there's a couple things we want to place here. We have the LED, the resistor, and these headers left. In another video, we already placed the DIP 16 package for the shift register. There is no specific package for the LED. not that I've found. What I end up using is the one for capacitors, which is cap 196. So we're just going to go ahead and type in cap 196, and that is how you spell it. All lowercase again. Just make sure it all matches up with exactly how this is written. So we're going to go in, edit part, edit properties. Go all the way over and put cap 196. Then X out of there. And we do that for all the LEDs. Another thing you can do is highlight and select all of the parts that you want. I'm going to have to edit that out of the video. There we go. So you can highlight all the parts like that, or you can select individually, which we'll do here in a second. So you can do this and drag down, and now all those are cap 196. So we're going to do it another way here in just a second. Edit that, and now you can see that all these have the footprint. And that's also the same footprint you'll use for those simple capacitors, like bypass capacitors, and any of that. For the resistors, we don't have anything, so if you want to select multiple things, select, control. Oops, we don't want that. Oh, I'm not going to select it. Okay, so control. So now that we have all the resistors highlighted, go in, edit property, and PCB footprint, but we don't know what we want to use right now. We can go back here, and all the resistor ones are called RES. The number after RES for how far apart the two connections are. If you look on a breadboard, that grid is 100 mils. So a 400 mil is 4 rows across on a breadboard. 500 is 5 rows across. The one that I always use for a standard resistor is Res 400. So RES 400. And then you can click and drag that. And just check that it's there. So if you were to go in and measure, that would be 400 mils or 4 rows across on a breadboard. And now we need 2 more things real quick. We need both the headers. For a header, what I end up using is the same as the jumpers. It's a very common thing, and if we just type in jumper, let me spell that right, you can see a couple different types. Here you see ones with a single digit after, and then the other ones you see with 300, 200. The differences between these are side by side 100 millimeters apart, and we'll go ahead and put both these on or that was a 2, so we'll go ahead and do a 2 and 200 to show you the difference. But these are the amount of pins going out, and this one is a space. So this is a single jumper going across 200 millimeters. This is 2 jumpers side by side. So let's go ahead and do that real quick. Actually, it's going to be easier to do that with one of the other ones. So we're just going to do jumper 2 real quick for that one. And you can see that that's done. So let's do that with this one. Again, there's a jumper 4 and a jumper 400. So we'll just go ahead and do I'll show you what 400 looks like real quick. So you can see here what it's saying is that this pin and this pin are 400 millimeters apart, something essentially equivalent to what the RES 400 was. That's not what we want, because we want 4 pins that are 100 millimeters apart, which is what a standard header is. So we'll go back into the part, edit properties, and make that jumper 4. And now you can see that it's 4 pins across, and that's exactly what we want. So now we have all of our footprints assigned. And if you're not sure if something's assigned or not, you just go through, you can click on it, or when we do the DRC checks later, it'll say that there's not a footprint assigned. Here we're going to talk a little bit about renaming components. For instance, you have a resistor, but you don't have a value. You never want to change the part that says R and the number. If you make these the same, you're going to have issues in your components because this is what identifies each different one. And the R represents the resistor, D is for diode, U is for IC, J is for jumper or headers. So you never change those. You change the label underneath. So for this one, we would just say 1K for 1,000. Oh. And we do that for each part. If we had a different thing, like let's say we want to put that SN HC74, we could go ahead and do that in here, even though the library doesn't have that listed as that. That's just one of the things you want to watch out for, and make sure that you're not putting spaces again in these. Something about Cadence doesn't like spaces in the names. It can cause some different weird issues. So here we're getting close to moving this over to a PCB. In reality, you would want to make this a little bit cleaner, put some of the systems over and separate them with the lines like we showed in another video. But right now, what we're going to end up doing is creating the netlist. So you can see that this pin is connected to this pin electrically, and it understands it inside Cadence. But in order for that to be created, what you have to do is go up to Tools, and then Create Netlist. Just go ahead and do the default, and let it create it. And it's going to save it, so make sure creating issues. And here we ran into an issue. So in order to show an error, I took the footprint off of one of the LEDs. If you're missing any footprints at all, then you're not going to be able to create a netlist, because what that's doing is saying how everything's connected to everything else. And this has nothing to connect to because it has no pinouts. So we're just going to go back in here, edit the properties real quick, and put the cap 196 back in. So now that has it, go back and create the netlist. And once it's all done, the netlist is created, and that should be good. And then we're going to go to PCB and do what's called DRC, or design rules check. Go ahead and leave everything as it is and run it. And if you don't get any warnings or errors, then your design is good to transfer over to a PCB. And that's what we're going to do here in just a minute. Okay, so here we have all of our footprints assigned. We've created the netlist, and we've done the design rules check. Everything's checked out, and we're good to go ahead and make a PCB. What we're going to do is go to PCB, create new layout. Your import board file, you're going to go ahead and leave blank. And click OK. We're going to use PCB Venture. If there's a new product that Cadence comes out with after this video, then just figure out which one it needs to be or talk to the professor. But PCB Venture is what we're going to use for now, and click OK. And now we have nothing. This isn't wrong. This is exactly what we should be seeing, because when we go up here, you go to place and manually, and now you see all of your components that you have. And this is where you're going to go to start to place all your components.